last lecture we have seen how to make transformer connections when the phase group such that the high voltage and the low voltage side line to phase voltages are either in phase or out of phase, that is either they have clock number 0 or 6. Now, let us look into some transformer connection where the clock numbers are either 1 or 11, that is the line to neutral phase voltage of the LV side leads or lags the line to neutral voltage of the HV side by plus minus 30 degree. What are the transformer connections in these two groups? For example, they can be D Y 1 or Y D 1 or Y Z 1. This can also be interchanged. However, DZ 1 is not possible. We have seen that DZ 1 is not possible. It can be either DZ 0 or DZ 6. DZ 1 is not possible, or 11 similarly is not possible. This is minus 30 degree connection. For plus 30 degree connection, you can have D Y 11 or Y D 11 or Y Z 11. Similarly, D Z 11 is not possible. So, let us look at this is plus 30 degree connection. So, let us look at how we make these connections. Let us start with D Y 1. D Y 1. So, the line to neutral voltage of the high voltage side, let us say this is the line to neutral voltage of the high voltage side. This is A, this is B, this is C. Again, let us say this is the terminal A2, this is B2, this is C2. Similarly, on the low voltage side, the low voltage side line to neutral voltage should, since this is 1, it should lag the high voltage side line to neutral voltage by 30 degree. So, this should be A, this should be B, and this should be C. Similarly, let us say these are A2, B2 and C2. Then obviously, these are A1, B1 and C1. Hence, it is imperative that the high voltage side line voltage A1, A2 be parallel to the low voltage side line to neutral voltage A1, A2. So, in this case, this terminal will be A1. So, that the phasor A1 to A2, this is the voltage phasor A1 to A2 is parallel to the low voltage side voltage phasor A1 to A2. Similarly, B1, B2 should be parallel to this voltage hence this terminal should be B1, so that this voltage phasor is parallel to this, and then this should be C1, so that this voltage phasor is parallel to this. Hence, connection wise it will be this is C1, C2. These are the terminals A, B, C. These are the terminals small a, small b, small c. The neutral point is formed by connecting A1, B1, C1. This is N. On the delta side, now we see that the connections are slightly different. Here B1 is connected to A2, C1 is connected to B2, and A1 is connected to C2. This is the voltage phasor diagram and the connection diagram of the phase group dy1. Let us similarly look at yd1. In yd1, on the high voltage side, this is, let us say, A1, A2, A1, A2, this is B1, B2, this is C1, C2. Hence, this is the neutral point N. On the low voltage side, we have the voltages A1, A2, which is parallel to A1, A2 here. We also have voltage B1, B2, which is parallel to the high voltage side voltage B1, B2, and the voltage C1, C2, which is parallel to high voltage side C1, C2. Hence, the line to neutral voltage of the low voltage side, calling this to be terminal A, this to be terminal B, this to be terminal C. We see that the line to neutral voltage on the low voltage side lags the line to neutral voltage of the high voltage side by an angle 30 degree. So, this connection gives me YD 1. Generally, for high voltage side, the representing letter is written in capital. For low voltage side, the representing letter is written in small. So, from connection wise, it will be neutral point is formed by connecting A1, A2, A1, B1, C1. Supplies are given to the terminals A2, B2, C2. On the low voltage side, you have again three windings A1, A2, B1, B2, C1, C2. In this case, the terminal A is formed by connecting A2 to C1. This is terminal A, and terminal B is formed by connecting A1 to B2. This is terminal B. Terminal C is formed by connecting B1 to C2. This is terminal C. So, this is the connection of YD1. So, this is DY1 connection, this is YD1 connection. Let us look at these were both were minus 30 degree connection. Here also the line to neutral phasor voltage phasor of the low voltage side lags the line to neutral voltage phasor of the high voltage side by an angle of 30 degree. Let us see some plus 30 degree connection, that is DY 11 connection. Again input side this is terminal A, this is B, this is C, which means this is A2, B2 and C2. Where is the terminals A1, B1, C1? That is what we will have to see. Now, here we are specifying that this is DY 11, hence the low voltage side line to neutral voltage must lead the high voltage side line to neutral voltage by 30 degree. So, this should be the line to neutral voltage of phase B, this should be the line to neutral voltage of phase A, and this should be the line to neutral voltage of phase C. So, this terminal is A2, this terminal is B2, this terminal is C2, and this terminal is A1, this is B1, this is C1. Hence, the winding voltage phasor A1, A2 is in this direction. This should be parallel to the winding voltage phasor on the high voltage side. Hence, this terminal should be A1, so that the line to the winding voltage phasor capital A1, A2 is parallel to the low voltage side line to the winding voltage phasor A1, A2. Similarly, this should be terminal B1, so that B1, B2, capital B1, B2 is parallel to small b1, b2, and this should be the terminal C1, so that capital C1, C2 voltage phasor is parallel to small c1, c2, voltage phasor. The connection wise, A1, A2, B1, B2, C1, C2. The Y point is formed by connecting A1, B1, C1, supplies are given to A2, B2, C2. This is terminal A, terminal B, terminal C. On the delta side, we find that A2 is connected to C1, then A1 is connected to B2 and B1 is connected to C2. This gives me, and the supplies are given to these points A, B, C. Let us compare this connection with DY1. We see that the start side connection of both of them are identical. On DY1, we had connected A2 to B1, here we have connected A1 to B2, B2 to C1, B1 to C2, C2 to A1, C1 to A2. Therefore, just by interchanging these connections, a DY1 transformer can be converted to a DY11 transformer. Similar conclusion can be drawn for YD1. Let us look at that. So, let us see the transformer connection YD11. The high voltage side is Y connected, therefore, the line to neutral phasor are also the winding voltage phasors. Hence, this is line A or winding terminal A2, this is line B winding terminal B2, this is line C winding terminal C2, and these are the winding terminals A1, B1 and C1, which forms the star point N. On the low voltage side, the winding voltages will be in phase with the high voltage side winding voltages. So, this will be A1, A2, this will be A1, A2, and then this will be C1, C2, and this will be B1, B2. if we want the line to neutral voltage of the low voltage side to lead this, then this connection if we make, if this is the connection, however, this does not give YD11, it gives YD1. Hence, this connection cannot be accepted for this case. Hence, the connection will be like this: A1, A2, B1, B2, and C1, C2. In this case, if we make this connection, then the line to neutral voltage of the low voltage side will lead the line to neutral voltage of high voltage side, and this will be a YD11 connection. So, what will be the winding connections here? This is the high voltage windings, this is not acceptable. On the high voltage side, the star point is formed by connecting A1, B1, C1. This is the neutral N. These are the line terminals A, B and C. On the low voltage side now, we connect A2 to B1, B2 to C1 and A1 to C2. The lines are connected to A2, B2, C2, A, B, C. Now, let us compare it with the connection YD1. When we compare, we see that in this case, the high voltage side connection of both the transformers are identical. On the low voltage side, while in this case A1 was connected to B2, B1 was connected to C2 and C1 was connected to A2, here it has been reversed. Here A2 is connected to B1, B2 is connected to C1 and C2 is connected to A1, but in both cases the lines are obtained from the terminal A2, B2, C2. So, this is the difference between YD1 and YD11 connections. Now, let us look at a interesting aspect of these connections. Let us take two connections, YD, a connection of DY1 11. The DY11 connection was like this. A1 was connected to B2, B1 was connected to C2 and C1 was connected to A2. And the terminals were obtained from A2, B2, C2. On the low voltage side, we had this is A1, A2, B1, B2, C1, C2. This was originally DY11 connection. Now, let us see the supply is given to high voltage side with A phase connected here, B phase connected here, C phase connected here. Now, let us exchange two terminals B and C of the supply, that is, instead of connecting phase B to this, if we connect phase C here, and instead of connecting phase C to this, if we connect phase B here, then let us see what happens. So, what is the winding voltage now? This supply phase sequence is ABC. This is A, this is B, this is C. If we interchange, then what happens? The winding voltage phasor V A1 A2 is now the line voltage V AC. The voltage of terminal A2 with respect to A1 is now the line voltage VA with respect to C. So, this is the line voltage, this is A2, this is A1 as well as B2, this is A2 as well as C1. Similarly, the winding voltage B1 B2, that is B2 with respect to B1, is now voltage VC B. VCB, this is terminal B1, and the winding voltage V of C2 with respect to C1, this is also C2. So, this is the voltage phasor C2 C1. So, let us see. So, now we have the line high voltage side line voltage phasors of this. So, on the low voltage side, the voltage phasor B1 B2 will be, this will be B2, this will be B1, A1 A2 similarly will be, this will be A1, this will be A2, this will be C1, this will be C2, Now, let us also exchange the terminal on the low voltage side. Let us call this the C phase and let us call this the B phase. Hence, this will be line A, this will be line B, this will be line C. On the high voltage side, this is line A, this is line B, this is line C. So, we see in this case line to neutral voltage phasor on the high voltage side is this. This is the A phase line to neutral voltage phasor. On the low voltage side, on the other hand, the line to neutral voltage phasor is this. Hence, the low voltage side line to neutral voltage phasor now lags the line to neutral voltage phasor of the high voltage side. Hence, this becomes effectively a DY1 connection. So, we see that we can very easily convert a DY11 to DY1 by simply exchanging two terminals, external terminals. There is no need to change the connection, internal connection of the transformer windings. This is sometimes useful, particularly while connecting transformers in parallel. As we will see, for parallel operation of three phase transformers, it is essential that the line to neutral voltage phasor of both the transformers should be in phase. Now, let us see how the zigzag connection can be handled. So, let us first take up the case of YZ1. As we have seen that DZ1 is not possible. So, input side is Y connected, hence the line to neutral voltage phasor is same as the winding voltage phasor. So, let us say this is your A phase, this is B phase and this is C phase. This is terminal A, B, C lines. Hence, this is also A2, this is B2 and this is C2. This is A1, B1, C1. On the low voltage side, we will have 6 such phasors. A1, A2, A3, A4. B1, B2, B3, B4, C1, C2, C3, C4. Since this is DZ1, the low voltage side line to neutral voltage phasor must lag the high voltage side line to neutral voltage phasor. Therefore, the line to neutral voltage phasor of the low voltage side should look, this should be C, this should be A and this should be B. How do we obtain this? From using this set of winding voltage phasors and with the constants that the last leg of the winding should be made of the same phase, that is A phase should be either A1 A2 or A3 A4, usually it will be A3 A4. So, we want to make this phase, let us say using A3 A4, this is the phasor A3 A4 which is in phase with capital A1 A2. Hence, what should be this one? This can be, this phasor should be like this. From here we see that it should be C1 C2, that is this is C2, this is C1, because this is in phase opposition to this. Similarly, for B phase we will have B3 B4 . Hence, this phasor can be only A1 A2. For the C phase, this is C4, hence this phasor can be B1 B2. As far as the connection is concerned, we have 3 windings on the high voltage side, A1 A2, B1 B2, C1 C2. The star is formed by connecting A1 B1 C1. The lines are given to A2 B2 C2. This is line A, this is line B, this is line C. On the zigzag side we have 6 windings. A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. The star point, as we see, is formed by connecting A2 B2 C2. This is the star point, and lines are taken from A4 B4 C4. This is line A, this is line B, this is line C. Internal connection wise, we find that A1 is connected to B3, B1 is connected to C3, and C1 is connected to A3. That completes the connection of YZ1. This is the YZ1 transformer connection. So, the last connection that we will see will be the YZ11 connection. since YZ 0 or 6 is not possible. So, here again the high voltage side is star connected, hence the line to neutral voltage phasor is same as the winding voltage phasors. So, this is line A, this is line B, this is line C. This is the neutral point, this is also terminal A2, this is terminal B2, this is terminal C2, and this is terminal A1, this is terminal B1 and C1. On the low voltage side again we have 6 phasors. A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. In order to have a YZ11 connection, the low voltage side line to neutral voltage should lead the low voltage side line to neutral voltage should lead the high voltage side line to neutral voltage by 30 degree. Hence, for the YZ11 connection, the line to neutral voltage on the low voltage side should be like this. This should be the line B, this should be the line A, and this should be the line C. Let us see how we can obtain this kind of line to neutral voltage using this winding voltage phasor, with the constraint that the last leg should be formed with the same phase voltage, preferably the second set. So, this should be A3, A4, A3, A4, hence this phasor can only be B2, B1, this is B1, this is B2. Similarly, for B phase, this should be B3, B4, this should be C2, C1, this should be C4, C3, and this should be A1, A2. Connection wise, this is the high voltage side windings, There are 6 windings on the low voltage side. A1, A2, A3, A4. B1, B2, B3, B4. C1, C2, C3, C4. Again we find here that the star point is formed by connecting A2, B2, C2. From this phasor diagram we find that the star point is formed by connecting A2, B2, C2. So, this is the neutral. The lines are still obtained from the terminals A4, B4 and C4. This is line A, this is line B, this is line C. Now, internal connection wise we find that A1 now is connected to C3, A1 is connected to C3, B1 is connected to A3, and C1 is connected to B3. This completes the connection on the low voltage side. On the high voltage side, as usual, the neutral point is formed by connecting A1, B1, C1, and the lines are supplied to A2 gets A, B2 gets B, and C2 gets C. This is the connection diagram for YZ where we find that the line to neutral voltage on the low voltage side leads the line to neutral voltage on the high voltage side by an angle of 30 degree. It will be interesting to compare the connections of YZ1 and YZ11. This was the connection of YZ1. We find that the high voltage side connection on both sides are identical, that is expected. On the low voltage side, in both cases the star point is formed by connecting A2, B2, C2. However, for as far as then the lines are obtained in both cases from A4, B4 and C4. However, as far as the internal connections are concerned, here we see that A1 is connected to B3, in this case A1 is connected to C3, B1 is connected to C3, here B1 is connected to A3, C1 is connected to A3, here C1 is connected to B3. This is the only difference between the two connections. The implication of this will be clear if we look at the two corresponding phasor diagrams. We see that on the low voltage side, in both cases the last leg of the phase is formed using A3A4, B3B4, C3C4 in both cases. However, the initial part on the YZ1 connection required C2C1, whereas YZ11 connection required B2B1. Hence, in YZ1 the A phase is formed using A phase and C phase, while YZ11 A phase is formed using A phase and B phase. That is the difference. The rest of the connection for these two are same. Thank you.